Okay, this is Unit 1, Scholarly Activity, Fire Behavior Explained. So fire is both useful and dangerous in equal measure. Firefighters need to be fluent in the different classes of fire, the fire growth process, as well as the different types of flames. Other fundamental concepts for us to know are the combustion process, the fire triangle, the tetrahedron, and smoke safety guidelines. And understanding of these important concepts helps us manage fire and minimize its effects on lives and property. So let's talk about the 5 classes of fire. Class A is developed from solid materials such as paper, wood, fabric, plastics, etc. It is the most common class, and it's known for intensifying very quickly. Firefighters should extinguish these fires as quickly as possible using either water or a monoammonium phosphate. Air pressurized water or APW extinguishers are also very common in most buildings and should be used for Class A fires. Multi-purpose dry chem extinguishers with an ABC rating are also common in industrial settings to extinguish these types. Class B fires now. These fires develop from combustible liquids and gases. Class B fires are mostly started with petroleum-based products such as kerosene, gasoline, etc. This process of putting out such fires entails locating the source of the fuel and shutting it off. Shutting that fuel supply off reduces the chance of an explosion. And after switching off the source, the fire can be suppressed using a CO2 fire extinguisher or foam. Water should not be used in extinguishing Class B liquid or gas fires. Okay, so Class C fires are developed from electrical faults and equipment such as transformers, motors, servers, fuse boxes. Class C fires are common in data centers and old buildings with poor wiring. Water is not preferred in putting out such kinds of fires since it's a good conductor of electricity and could lead to electrocution. Water should only be used after unplugging or de-energizing all electrical equipment, and more commonly, like a clean agent suppression comes in handy since it's non-conductive and does not damage sensitive equipment. So Class D fires are usually ignited by flammable materials such as magnesium, aluminum, titanium, and often from just flakes or powder from these materials. This is not the most common type of fire, but can be difficult to extinguish. Dry powder is used for putting it out, and the dry powder separates oxygen from absorbing heat, ultimately smothering the fire. So Class K fires are usually ignited by animal fats, vegetable oils, grease, and usually cooking appliances. These fires are very common in commercial kitchen restaurants and can be catastrophic. Neither water nor CO2 should be used to extinguish them, as they can easily cause an explosion. In domestic settings, usually a wet blanket or baking powder is used to extinguish it. In commercial settings, they usually have a hood system, a special system with a K rating that extinguishes them. All right, so moving on to a premixed and diffusion flame. So a premixed flame develops when fuel is mixed with an oxidant before the reaction. A classic example of that is a Bunsen burner or your stovetop. Diffusion flame, on the other hand, is where the fuel and oxidant are still separate but interfaced. The mixing and combustion process occurs simultaneously in the process. A candle flame is an example of that. And most large fires are a diffusion flame. The major similarity is that there's combustion in both types of flames. However, premixed flames tend to have a narrow reaction zone compared to a diffusion. The burning rate is also different between the two. And for premixed flames, the rate of combustion is relatively steady. For diffusion flames, the overall rate of combustion depends on the rates at which the oxidizer and fuel are brought together in the right proportions. Okay, so combustion and combustion efficiency. Combustion refers to the process where fuel combines with oxygen to generate heat. Combustion efficiency refers to the degree to which combustion process is completed to produce that heat. Combustion efficiency is heat released rates are generally higher in well-ventilated areas, and the combustion efficiency also varies across different types of fuels. Notably, combustion efficiency is higher in premixed flames compared to diffusion flames. So let's talk about the fire triangle and tetrahedron. So for the longest time, the triangle has been used to explain fire dynamics and the key components requiring to ignite it or sustain it. These components are an oxygen or oxidizing agent, heat, and fuel. Oxygen is essentially what keeps the fire burning. The oxygen in the air is essentially to sustain the combustion process. For a fire to ignite, there has to be a source of fuel. The type of fuel determines the class of fire. The third and last component in the fire triangle is heat, which is necessary to ignite it. The tetrahedron, on the other hand, also referred to as the pyramid, introduces one more component to the fire triangle, the chemical chain reaction. It was established that a fire could not stand without a chain reaction, and that chain reaction is an exothermic reaction that keeps the fire burning. The fundamental difference between the triangle and the tetrahedron is that the latter has a fourth element, the chemical chain reaction that's needed to sustain itself. So dangers of smoke. So smoke is a poisonous gas and can possibly reignite if given enough oxygen. The combustion process in the different classes of fires produces carbon dioxide and carbon monoxide. Continuous exposure to carbon monoxide leads to elevated levels of methylglobin, which can cause respiratory failure. Firefighters must be cognizant of the dangers in smoke and make use of personal protective equipment when they're around it. Generally, fires with huge flames, diffusion flames,